Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Jacob. Hi, Jacob. Tell us a few words about yourself and about the tool you want to show us.
Hey, Alexey. I'm Jacob. I am a senior machine learning engineer and researcher at Voxel 51. At Voxel 51, we build the open source toolkit 51, which is the leading open source toolkit for curation, visualization, and management of visual data. So think everything from images to videos to point clouds like LiDAR and radar to recently added meshes and stuff like that. Basically, we just want to help people to bring structure to their unstructured data and understand it better so they can build better data sets and train better models.
Why 51 though? Does it have to do does it have anything to do with the area 51 or something else?
That's a great question. I think I'm not the founder of the company, but the founders have their own mythology around the naming. They like to say that they had 50 bad ideas before 51, but
Ah,
you should ask them.
okay. Well, I'm satisfied with the answer. Okay, you have a demo for us, right?
I do have a demo. I will share my screen. Okay, great. So we're right now working in a VS Code notebook, but you could be doing this in a Jupyter notebook, Databricks, in a standalone Python process. From the command line, there's even some syntax that you can use. But the basic idea here is that 51 is a Python library plus a visualizer that allows you to programmatically query and work with your data, as well as to visually interact with it dynamically. So it's very easy to install. You can just hit install 51. You can do this from the command line or in a Jupyter notebook, however you'd like. Once you do that, then you're going to want to import 51 and then a couple of modules. So this is all of the importing that we're going to be doing. I promise you it gets simpler from here, but this is the base module, the base library itself. The zoo is a module within 51 that gives us access to a bunch of like pre-organized data sets and models for us so that we can, from the start, have a bunch of things to play around with. So all of your traditional image and video data sets that you're familiar with, things from ImageNet to Cocoa to the Berkeley Deep Drive data set and so many more, you can load in without writing any custom code and parsing. And the 51 Brain is going to give us access to a bunch of custom analysis and machine learning tools. So at this point, we can create a dataset object. So we're going to take the FOZ 51 zoo and load a zoo dataset here. We could also list out all the datasets that we have access to, and this right here gives us this long list of data sets that we can access without writing any custom code. But the true power in 51 comes when you use this with your own custom data. And it's very easy to do that as well. But it's easier to show you the functionality of 51 starting from an existing data set. So we're going to load this data set, as I've done. I'm loading 1,000 samples from the validation split of the Cocoa 2017 dataset. And I have launched the 51 app here. I'll rerun this command, and we can see this basically creates a session object with this data set in it. And auto just means that it's not going to display in the output of a cell in the notebook, but you could also work with this data set in the app in the output of a cell in the notebook. But the cool thing about these sessions is they give a one-to-one correspondence. There's a two-sided compatibility between the query language, the Python code we're running, and the app, these like dynamic UIs, which are going to be updating and allowing us to make changes to interact with the data set. So they go back and forth. They're completely intertwined so that if you make changes in one, it's going to be reflected in the other. And here you can see the session is located at this URL, basically localhost server port 5151. I can click on this. I can go over to my browser and see it here. You could also view this in
Yeah.
a. So this is the 51 app. The 51 app is a very easy way to visualize and to filter and to interact with your data. So if you have ever worked with images and videos and 3D data before this, you might have used something like TensorBoard, or you might have just used the file browser on your computer and scrolled through the list of files and clicked on them one by one and tried to associate them with whatever labels file you had. Maybe you have some programmatic way of going through and actually identifying what sample and displaying it in matplotlib or something like that. But this is the data model is connected to the visualizer itself. So as you make changes, things will be displayed here. So I can look through them. I can go into an image and view all of the labels on it. For this data set, this is the MS COCO 2017 data set. So I have a bunch of detections from 80 classes, things like a vase, a TV, a chair, person, things like that. And I can look at these. These are the ground truth labels here, but if I had predictions, I could also visualize them. You could also visualize things like segmentation masks, key points. You can visualize heat maps, lots of different things here. I can get a sense for what these images and what the detections look like on these. So in this case, I have this big book detection, which accounts for the entire bookshelf. But some of the books are just individually detected, and maybe that's going to be a problem for my model. Maybe it won't. And these are the types of things that we can understand better when we look at our data and we see it more dynamically like this. But this is just the very beginning of what we can do. So let's start to go a little bit more nuanced here. We can do things like filter our data. So I can look at this label field, this ground truth label field that has my detections in it. And I can click this button right here, and I have a way to filter by label. So I can look at only the car detections. And I can say, do I want to see just all of the detections with label car, or do I want to see all of the samples that have the label car? So right now, you'll see that I have a bunch of images, but this cat is not labeled here because I only filtered for the detections that have car. So I have the car detection, but not the cat detection. But instead, I could do something like show samples with label. And when I do that, I get the cat as well. And again, there's so much more that you can do here. There's so many layers to this, but this gives you a way to, again, dig into the data more. So I could do things like once I have this, I'm just seeing all the cars, or just seeing all of the, let's go back to just the detections with this label. I can bookmark this and turn this into a view stage or a set of view stages. And this is a dataset view, which is going to programmatically encode this queried view into my data that I have constructed here. And this is something that you can do in code as well. All of the things I'm showing you in the app are things that are also able to be done in code. Everything that can be done in the app in FiftyOne and more can be done via code. But once I have this view bar here and these view stages here, I can do things like convert to patches. So I only want to see all of these patches. Now it's taken all of the detections from this filter view I had and narrowed them down. So I'm seeing just the subset of the image corresponding to that bounding box right here. And this gives me a way to look through all of the specific detections that I had, or you could use this to look at evaluation patches if you had ground truth and predictions, for instance. And here we can see a lot of these are pretty coarse grained. They're pretty low resolution. And this could be because the cars are small in our images, or it could be because maybe we have some erroneous detections, some false positives in our ground truth, or something else entirely. So far we've just been filtering, but there's so much more that we may want to do when we have a data set like this. We might want to look at our data and add some labels to it. So here I have an image that has some person detections, it has buses and things like that, but maybe I want to detect this license plate. Sure, I could train a model to do that, but before I train a full model, maybe I just want to use a zero-shot model to generate some initial detections on that. So I can select this image and I can type in 0 and go to my zero shot and select detection and choose a model. And I can then type in, for instance, license plate. And I can say, I want to store these. I'll call it LP. This is the field on my data that I want to store these detections on. And I just want to do this for the selected samples, in this case, the one sample. And I'm going to run this. And on the back end, this is taking this zero-shot model, it's running it, and it is generating a prediction, which is then displayed here. So this is just one example. You could do this with many other types of models. And again, this is just one particular type of workflow that you could want to do. But the cool thing about 51 is that once you have your data more dynamically and interactively available to you like this, then you can start performing and mixing and matching all these different workflows that you could want to do. So to show you just a few more that you might be interested in, we could, let's say, we want to take the first 100 images in our data set. So now I've limited from 1,000 to 100, and I'm going to compute something like the brightness across this view. And this is on the back end running a computation. It's going to take all these images. For each of them, it's going to run some routine to approximate the brightness. And I can display this on them, and I can see some value here. And then I can even filter by brightness. I can see the brightest images, pretty bright, or the darkest images over here. And I can filter by all these things programmatically as well. So these are just a few of the types of things that you could want to do, but the possibilities are really endless here. This is just for images, but it also works for videos. So let me show you with the videos. Let's load a zoo data set. I'll type in video here. And let's choose quick start video. So this is analogous to the first command that we ran in Python, which was taking our load zoo dataset and running that to generate the dataset and instantiate that object. But we've done the same thing in the app. And this is, again, showing you how you could do the same thing in both places. We can look at these samples. We can see that these are actually tracked. So this vehicle label, this tracking ID, this unique identifier, is preserved across all these frames. Same with this one, and we can see as we go forward, it's the same thing in all of them. And again, you could also see this with 3D, LiDAR, radar, mesh, whatever you'd like. So things start to get interesting when we begin to interact with our data a little bit more dynamically. So here's another data set. This is the quick start data set in 51, just 200 samples. It's also a subset of MS Coco, but you could do this workflow for any data set that you'd like. I'm going to take these images, and I'm going to generate a similarity index on these samples. So I'm going to here save this with something called ClipSim. So this is the way that I will be able to access the results from this run in the future. And I'm going to run this on the entire images, not detection patches. I will store the embeddings in a field called clip embeddings, and I'm going to use a clip model to do this. And here you can see all these models are models from the 51 model zoo. So like the dataset zoo, you have access to all of these models out of the box, but you could also use your own models and bring your own predictions and embeddings very easily. It's very, very simple to do that. So here we're going to do this. We're going to just do the simplest thing that we want to do here. So this is going to run through our 200 samples. It's going to generate these embeddings, and it's going to create an index out of them. And now if I refresh the app, I'll be able to do things like select an image and find similar samples to that image. So here I find all the images of cats first, because what this has done is it is generating some embedding using a clip model, which is a semantic representation learning model. And it has generated this index, which is basically taking each of these images and associating it with one of these embeddings And then whenever we have a query image, we're taking that embedding and looking through our set of embeddings, finding the embeddings that are closest and displaying the images or returning the images that are corresponding to those results. So here we get all of the cats. There's a lot more going on behind the scenes here, and you could use models other than CLIP. You could use tons of different models here. You could use vector databases as backends if you want. The point here is not that this is the specific workflow that you might be interested in. It's that this is an incredibly flexible foundation for tons of new workflows around your visual data. And I'm just going to finish up real quick here with two last things. So this index that we generated also allows us to search with text. So I could search for, let's say, a train. And now this is going to, here, I'll get a couple of trains at the very top here, but maybe not all of them because this is a semantic thing and there are multiple interpretations of the text train. So let's try another one. Let's say a train track. Let's see, we get some different results, or let's even do a different one. Let me just search for a bear. We get some bears at the very top here. So what this is doing is it is taking our images, which we've generated these embeddings for, and then we have our text, which we are also embedding, and it is using that text embedding as the query and comparing that to all of the images in our data set and returning the top results. So we can, in this multimodal fashion, interact with our data. But we can do even more than just doing these single query visualizations. We can look at the data structure more explicitly. So let's take the entire data set and let's generate a visualization. And we're going to use these existing embeddings that we have, and we'll use this UMAP method here. You could use PCA or TSNE. This is going to do dimensionality reduction for us. I'm going to hit execute, and this is going to take the embeddings that we've generated. If we hadn't generated them, it would generate some new embeddings for us. It's going to run dimensionality reduction on them, and then we will be able to click over to this embeddings panel over here. And we should be able to, in this case, we should be able to see the embeddings here, but they're not loading for the moment. But ideally, we'd be able to see all of the embeddings displayed in that plot over there. But the thing here is that it allows us to understand the structure of our data a little bit more. And this is not the only case where we can do that. So here, let me show you another one where I already have it calculated, I believe. So here is a data set for anomaly detection, and I have taken clip embeddings in the same way as I was just doing, and I have generated a 2D visualization of them. And I can color these by whatever I'd like. So I can say, let's color them by the label of the object type. And I can see that they're very roughly clustering by this object type. And we can dig in deeper and say, let's view only these, or let's view just this little cluster right here. So why is it that toothbrushes are clustered into these three little segments? Well, if we look at this one, we see one type of feature. If we look at this one, we see a different type, and we can see that the thing that differentiates them is the color of the bristles. So we can dig in deeper and again see a different color of bristles here. So all three of those are, the bristles is the main identifying feature. But we can color them by whatever we'd like. We can interact with these. We can, again, just dynamically explore and understand the structure of our data better. So I'll leave you with that. There's so much more we could do here. And again, everything that we were doing in the app can be done in code and so much more. But I hope that that gives you a sense for just how powerful FiftyOne is.
And do you think the main use case for FiftyOne would be initial data exploration, like you presented here, or more like we have a model and we want to visualize the performance of this model, like how well it predicts, or maybe both?
Absolutely. So FiftyOne is used by our open source users and then our enterprise users. at all stages of the data lifecycle. So we'd like to think about it in three main areas. One is this initial exploratory data analysis phase. One is once you have labels on your data, how do you find label mistakes? So how do you identify maybe things that were misannotated or edge cases and things like that? And then once you have a model's predictions, how do you identify where the model is failing and figure out where you need more data, where you might want to change the way that you're doing things a little bit, and so forth. And it's really used in a feedback loop.
Mhm. Yeah. So it's more for, let's say you're a machine learning engineer, so you implement a model and you want to just take a look at the predictions, right? To understand how well it performs, and this is how you use it, right?
Absolutely.
Mhm.
You
And
could, for instance, filter for high confidence false positives and look at all of those and see,
for debugging.
are some of those actually false positives, or
Mhm.
is the ground
Yeah.
truth wrong and the model's actually right, and so
Mhm.
forth.
Yeah. That's cool. And I was wondering when you were showing the demo, so you did, so your Jupyter notebook contained only two cells, right? So the first you had imports and then the second run server, something like that, run session. Would it work on Colab, Google Colab, or you need
It
to run it?
absolutely works on Google Colab.
Okay.
You can definitely do that. And a lot of our, if you go to our documentation, then every one of the tutorials in there has a button on it that says running Colab, and it just
Uh-huh.
takes you directly to Colab. And a lot of our workflows are more code based, because once you dive deeper into your data and you want a little bit more customizability, it is helpful to actually write some custom code. But if you're starting out, it's often easiest to just do the
Mhm.
UI.
Can you show us the next tutorial? If somebody is interested in 51, what would be the next tutorial we should take, like after watching this video? For example, something that also shows how to use the code.
Absolutely. So let me share my screen one more time. So this is the 51 documentation. I'll make it a little bit bigger again. The text might still be a little bit small, but if you just go to 51.ai or docs.voxel51.com, you'll see this here, and you'll be able to go through and see everything from the core functionality and features to things like tutorials, recipes, cheat sheets, user guides, and so forth and so on. A lot of the things that I showed you today are from this using the app section of the user guide. So this has things like how to uh, use the image visualizer and how to use the embeddings panel, and so forth and so on. There's so much that I didn't show you as well, but this is where we were located today. The place that I would go is to loading datasets. So if you go to this like 51 basics, loading datasets and using datasets, these are going to give you all of the basics of how you actually interact programmatically with your data in 51. It'll allow you to do things um, like add samples to your data set, to find all the distinct tags, to get the first sample and interact with the sample itself, or count things and create labels in your data, and so forth and so on.
Yeah, that's awesome. This looks like quite a big project, so I'm wondering how many people are working on it.
The team's about 30 right now.
Not 51.
We not 51 yet.
Not yet.
I'm sure that we'll have a big celebratory post on LinkedIn when we do. I know that we had a big fun LinkedIn post when our GitHub stars hit 5151, and that was a fun day. But the team's about 30 people right now. Most of us are engineers. It's a really awesome group of people, but we really rely on our community a ton. Like 51 would be nowhere and nothing without its tremendous open source community. And we encourage and really value our contributions and contributors.
Mhm. And if somebody wants to join your open source community and start contributing, how should they go about that?
So we have a really vibrant open source Slack community on the page that I was just on,
Yeah, I
docs.voxel51.com.
remember.
Okay, at the very top, there was a button that you could click on for Slack. There's almost 3,000 computer vision engineers, researchers, machine learning aficionados in there who are constantly answering questions, talking about their projects, contributing, and doing tons of cool stuff. So that's the place to be. I'm there. Everybody from our team is there all the time, and would love to see you there as well.
Mhm. Yeah, this is great. And I guess as the first step of joining the community, you should join Slack. But my question was about more about like if I want to contribute something. Do you have like good first issues, or maybe like once I join Slack, there is a special channel where I can say, hey, I want to become a contributor, or what are my next steps, or how should I go about that?
Absolutely. So there are multiple ways to do that. In the GitHub repo, we have issues tagged as good first issues. So any of those would be a great place to start. We also have a contributors channel in Slack. And then we have a couple of additional things that are really easy on-ramps into 51 these days. Plugins are a way to, without having to deal with the main code base itself, to get to play around with and add your own functionality to 51, which may in the future be added as a first class feature. But for now, you can just dabble with and try out different things. So plugins are a great place to get started. We have tons of documentation on those. We also have a plugins channel in our 51 Slack. And then another one is datasets. So what I didn't show you today, but what we're very excited about is our recent integration with the Hugging Face Hub. So now it is possible to push 51 datasets directly to the Hugging Face Hub and to load 51 datasets and Parquet datasets from Parquet format into 51 format directly from the Hugging Face Hub. So a lot of our recent contributions have been people in the community taking datasets they're working with. Either these are popular existing datasets or their own datasets that they have been pioneering or playing around with, and they're putting those on the Hugging Face Hub using our integration, which once you have the dataset loaded in, it's just one line of code to push to Hub. And that is an awesome thing to do, which will bring value to a ton of other people in the community.
I bet you have a plugin for GenAI, right?
We have multiple plugins for Gen AI. It's definitely a hot topic. Everything from visual question answering and image captioning to multimodal large language models to text to image models. We have a text to 3D. We have a image to video. All of the standard generative
Mhm.
AI things that you'd want.
But you implemented through plugins, right?
Correct. Those are all implemented through plugins.
Yay. I guess correctly. So, okay. Do you have any advice for anyone who is watching this?
My advice is that I know that this is a very large project, and it can be a little bit overwhelming to look at all the sprawling documentation and functionality. I would say focus on what your use case is. So if you're working with visual unstructured data, 51 can help you to make that easier. Don't worry about all the functionality that exists in 51. Just think about how can I make my use case easier, simpler? How can I streamline it for myself and maybe for others that I'm working with? And start there. Like start with the real value, and don't just think about the entire project. You'll get there eventually, but we as a community care about how we are helping people who are actually doing machine learning and computer vision work to facilitate their workflows. And I would say just start there.
Great piece of advice. And with that, we should be wrapping up. So thanks a lot, Jacob, for joining us today, for showing the demo. I'm sure many of us will find it useful. And please do not forget to give 51 a star. Uh, the link to GitHub probably is somewhere on the docs that you showed, right?
It's at the
So
very top of the docs as well, right
yeah,
next to the Slack.
yeah. So please go there, give them a star. It's an awesome project. Thanks for making it open source. And thanks again, Jacob, for coming today and doing the demo.
My pleasure. Thank you so much for having me.